This is our next video in the lesson 2.1, the tangent ratio. I just want to define for this word problem a couple of terms here. Angle of elevation or inclination is just measured from the horizontal up to something. So for example, let's say we're in a building or at this point on the left, and we're looking up at the top of the other building. The angle of elevation is measured not always from the ground, but from the horizontal up to the top. And that's an important distinction. Often we are on the ground, so the angle of elevation is just from the ground to the top of something, but it's always from the horizontal. Angle of depression doesn't come up as often, but is measured from the horizontal down to something that's below the observer. So if my observer stays in this building, but now looks at the bottom of the other building, the angle measured from the horizontal down to the bottom of that, to the base of it, would be the angle of depression. Bring that up because this question mentions one of those. So our question says this: if a town in Alberta has a latitude of 52 degrees north, determine whether this design for a solar panel is best. In other words, is the angle of elevation of this roof close to 52 degrees? Because if you have your angle close to the latitude angle, you'll be maximizing the amount of sunlight you collect. And so the picture is a little tricky here because they don't give us a right angle triangle. They give us the height of kind of the roof elevation there, and they give us this whole length across the bottom. And so what we have to do is say, oh, okay, well, half of that would make 4. And so the right angle triangle I can solve, which would give me this angle of elevation I'm interested in, is a 5 and a 4 on those two sides. So in this case, the opposite is 5 and the adjacent is 4. So I think about my trig ratios. Tangent is equal to opposite over adjacent. So tan of my angle is 5 over 4. And so to find the angle itself, I say inverse tan of 5 over 4, and I get 51.3 something degrees. And so, is it perfect? Well, not perfect, but it's awfully close, right? If you think of how small a degree is, we're talking about less than 0.7 degrees off. So this roof line for a house that's at a latitude of 52 degrees is just about perfect. If you added a sliver of height to that roof, I suppose you could make it 52, but pretty good nonetheless. And do make sure at the end of one of these questions that you actually do answer the question that was asked.